All right, and we are live. So sorry for the delay, everyone. We had a few things we had to chat about and some audio issues that came up. We'll get started with the podcast in just a moment, but we're going to do a bit of housekeeping first. All right, I'm going to record on my local syncing audio. That's what the clap is if anyone is new and doesn't know why I did that.
There you go.
All right. Hello and welcome back to Enterprise Linux Security. We're up to episode 118. We have four stories we're going to cover today that include a huge 16 billion password leak, or was it a leak? We'll actually talk about whether or not it's truly record breaking as we get to that story. We're going to talk about evil Minecraft mods and a potential performance boost for Ubuntu users that has a little asterisk on it. We'll get into that and some other security shenanigans. How you doing, Joao?
All good. As always, a pleasure being here with you. Yeah, we got a few interesting stories to cover today. We have 16 billion exposed login credentials, which made the rounds on all the news sites, but apparently it wasn't so. And people have been inflated the numbers all around, so we'll take a look at this definitely. We'll
Mm-hmm.
continue our trend of looking at AI related um, security issues because that's not going to go away anytime soon as people continue to
No.
use AI. That's just continue to happen over and over again. This time it's an interesting way to abuse LLMs. And like you said, we are going to cover Minecraft servers of all things. And
Yeah.
also Ubuntu, because
Yep.
everybody loves Ubuntu. You
Yes,
have
they
books on
do.
Ubuntu.
That's true. That has happened. Couple of things to mention real quick. If you want to support what we're doing, one of the ways that you could do that is to check out the shop at merch.learnlinux.tv and get yourself some awesome Linux swag. Every purchase helps out the channel, and I really appreciate it. And since we're talking about AI, I figure I should mention the Artificial Insanity shirt, which is one of the ones that I have on the shop. The Blue Screen of Death shirt, which is an interesting twist on that. Although in the news lately, apparently that's going to be the Black Screen of Death. But anyway, Blue Screen of Death is kind of iconic in the Windows world. So there's a shirt about that. Of course, with the Linux angle, just like everything else that's on the shop. Also, some other things like cups, drinkware, some really cool stuff. So just check it out at merch.learnlinux.tv. And another way you can support us is to subscribe to this channel. I am less than 10,000 away from a million as of right now. So I mean, it's a matter of weeks at this point. So I really appreciate everybody. I never thought that this channel would, have that high of subscribers. Not that I didn't think it was going to be successful. I always had a feeling that it would be, but I thought maybe 400,000 or 500,000, and that would probably be enough. But then it just kept growing and growing. It's overwhelming in a good way. It's incredible. I really appreciate everybody. So if you haven't subscribed, please do so. Let's get that number up. We're almost there. I appreciate you guys. So let's get started. And I think we should start off with the 16 billion password leak, which when I read this, it kind of seemed like the articles implied that there's a single database with 16 billion credentials. I hope I didn't say million. It's 16 billion credentials, which led me to believe that it's one resource with that much in there. But actually, when we go through the story and we read through it, it's kind of like, yeah, but no. It is noteworthy, which is why it's on this episode. But I think we have to add a little bit more truth to this and kind of just frame this in a more realistic sense when we talk about this development.
Absolutely. Like all stories of this type, it begins in the dark web because it's scary. It's a catchphrase for all of these types of shenanigans, and people love a good dark web story. So yeah, it came out that there was this leak of 16 billion with the B credentials out there, which is massive. In fact, it was supposed to be the biggest leak up to now. These records keep getting broken, but again, biggest leak so far. But when people started looking more at this, and just to clarify, this isn't available anymore. So you either saw it at the time or got access to it at the time, or you don't get access to it right now. Um, this was in fact a collection of about 30 databases, some very large ones, others not so much. Um, it had the it seemed like it was all new data. Not all of it turned out to be new. Some of it has been just a compilation of previous leaks, but the majority of the data was either very recent or was from stuff that had not been seen on dark web forums previously, and that immediately raised some eyebrows. So
Yeah, and like I mentioned, you read the headlines, and the stories are already linked in the show notes, and it'll be uploaded on the main website shortly. But it when I first saw the headline, like I mentioned, I'm like, wow, that's a big leak. But there's a lot of overlap between them. Well, I shouldn't say a lot, but there's some number of overlap between the 30 different databases. And some of the information might be in one database, might be in another database, some credentials might be in more than one. And we're talking about all the major players, basically email providers, VPN providers. I mean, you name it, it's probably in there. And when you have this information, that's out there, of course, threat actors are going to try to use it to get into people's accounts. And even if just a small percentage of these credentials, work, that's a large number of people that could actually fall victim to this. And we're talking, account takeovers, identity theft are easy possibilities here. Very targeted phishing schemes can be constructed from this information. And just like Joao said, it was there and then it was gone. But the information does exist somewhere. But it's just questionable whether we could count this as record breaking, being in multiple databases. When it comes to overlap, I mean, how much does that lower the number? So there's some questions here, but what's not in question is how useful this information is to threat actors, because the stuff like this is basically like their playbook, so to speak.
So the difficulty with finding out if there's any overlap comes from a series of factors. The most important one being that all of the different databases have different formats for the data. So making sure that you get the right queries to compare these, it's difficult, and it wasn't available for long enough to actually get that. This was available on unsecured Elasticsearch databases, which is typical of these types of leaks. They usually show up in these things, and that's where it gets divulged. A very interesting threat vector for this, and I didn't see this mentioned in the article, is that this can be used not just against online services and online data and services and authentication services, but it can be used against cold data and stored data that the threat actors have exfiltrated somewhere, for example, during a ransomware attack, and where they copied the data first. They can use this repository of passwords and credentials and try to get into that now, which makes it incredibly useful. This might not have been that big of a deal, first because it was available for very little time, but on the other hand, this was being placed online and accessible for somebody. These type of things are usually sold. Access to this gets sold, so it's not unreasonable to believe that somebody got access to it and bought like exclusive rights to it. There are groups out there that have more than enough resources to do that, and it's still very useful. You mentioned the email providers. This contains data for Apple, Facebook, Google, GitHub, Telegram, government platforms. There's lots of stuff there. The information on the article, it mentioned, for example, that one of the largest databases there uses might be related to Portuguese users. It isn't. It's just that the name happens to coincide with some slang term that's applied to Portuguese users. It doesn't. It's not related at all with that. It's just random services.
Yeah, and sometimes it's really hard to know where these kinds of things originate from, especially considering the people that steal this information. They really don't want anyone to know where they are. That said, often there's something about it that kind of points to a certain location, but in actuality, a lot of these groups have people from various locations, or they're tunneling their connections through multiple different countries before they get to the target. So yeah, that's always kind of hard to assess. In addition to that, it said that cookies and session tokens are among the data that was stolen. And that's the kryptonite to two-factor authentication, because if you have a valid session, you have a valid session.
Yeah.
And if someone steals your session, they have your session. So, and obviously that's not something you want anyone to have. So, obviously we recommend two-factor authentication to everybody, but no protection, no matter how good it is or how useful it is going to, get you to 100%. It's just the least you can do. But, threat actors are always trying to sidestep pretty much everything, and two-factor authentication isn't beyond that. But it is said that that's part of the leak as well, which could get people right into an account very easily. So
It's interesting as well that one of the things that's mentioned in the story is that this was built primarily by using something called an info stealer. It's a malicious program that runs in your system that gets there the same way that the ransomware gets there. But instead of making a flash and encrypting your files, it just sits quietly there and tries to get all the passwords that you have stored, and the session cookies and the tokens that it sees, and then it gets all of that nicely packaged and it uploads it to a command and control server somewhere, and that's how the data gets leaked from your system. It's interesting that you mentioned the two-factor authentication, and we recommend that. This story made Google come out and announce that they are going to make a push towards passphrases. Passphrases are more secure than two-factor authentication, in that even if a service gets hacked and all of its data gets leaked, there isn't enough data in the service side of things for anything to be compromised. Part of the passphrases and the reason that they work better is that part of the authentication mechanism always stays with you on your device, and the other part stays with the service. None of the parts by itself is enough to get you into the service. You need both sides working together to get you into the service, meaning that it would essentially defeat all of these types of attacks. So Google says that they are going to push towards passphrases, so don't be surprised if you start seeing a notification somewhere in Google, in the dashboards or in any of their services, requiring you to set up passphrases. Because while they said that they will not directly contact any user asking to do that, again, if you receive an email from Google or from Microsoft or from Apple saying that you need to change your password or your credentials, it's fake. Somebody is trying to get your current credentials. But they will start requiring passphrases somewhere, because even though many people use multi-factor authentication can still be attacked like this.
Exactly. Yeah. And I don't know. It's just really hard to ascertain exactly how record-breaking this is, like we mentioned. But one thing that is clear is that if your password just so happens to be among those that are part of this breach, then, well, hopefully you change your passwords regularly, and then it doesn't matter. Obviously, this is going to hit the users that don't change their passwords ever. They have the same password for the last 5 years on a service. Service was hacked a few years ago. It's still a part of that service. So obviously, as much as we hate password changes, every now and then, I mean, that we do have to roll our passwords. There's a number of things that we really do need to do to stay vigilant, but it's not just about this story, because the things that we should be doing, I hate to say best practices or minimum practices, as we like to say, it could definitely help you out and help invalidate some of this data, but it's especially powerful for threat actors if the information stays the same, since the information was leaked, because some of this information came from a while back. It's not all new. I'm sure maybe some of it is, but this is a collection of 30 databases worth of information across several different sources. So it's not insignificant.
If you have an account on some online service, if you have an account on the social network, and that account is over a year old or 2 years old or something like that, it has essentially been part of a leak somewhere. Use Have I Been Pwned. It will tell you if your account has been leaked or not. The short answer is yes, it has. So you should be rotating your passwords anyway. You shouldn't be repeating passwords across multiple services. But again, that's just basic password hygiene at this point. And you should definitely look into passphrases. They're much better than, again, normal passwords. They're much better than multi-factor authentication, and they're essentially immune to this type of leaks. Because even if it's not 16 billion, if we shave off 6 billions of this leak, it's still massive. everybody's going to be hit by this. So again, change your passwords if you're using anything online and you're essentially using it. Um, and you're going to get in one of these leaks. There's not much you can do. You can't control the services that store the data. They'll do whatever
Right.
they have to do. Sometimes it's not the best solutions that they use for data storage and data security, and they will get attacked. The data will be out there in the open for everybody to see. It's part of life of being online at this point.
Yeah, and when you have big services like the Facebooks and the Googles and all of those, I mean, there's a lot of people that are developing this, and we have to remember, to be human is to be imperfect. And no matter how good of a system administrator you are, you're going to make mistakes. And I'm sure many of us, especially people listening to this podcast, have had situations where they start working at a company, they had their first week on the job, they start looking around to try to learn the company and their systems, and they find things like, why are you doing this, or why is this in clear text, or this is vulnerable. I mean, it's often the case, not because anyone's lazy necessarily, it's just because people make mistakes. And then when you have something on the scale of Facebook or Google, then the likelihood for error is much higher. There is no such thing as an online service that's perfect. No matter how good the company is, no matter how much money they throw at security, all it takes is one small mistake and then information leaks out. So, and just like Joao said, if you've had an account for a while and you haven't changed your password, it's on a database. The Have I Been Pwned website, I've shown it to a few people and had them type their email address in there. And the reactions every single time have been shocking. Like, I haven't had one person that I showed this to that didn't have something on there. Like it is such an easy service to check, because literally all you do is go to the website and you type your email address in. So you can send this to somebody. I prefer to do it in person because, you don't want to trust links from anyone, and you don't want to facilitate that. But if you're with somebody and they start talking about security, just say, hey, go to this website, type your email address in there. And the look on their face is absolutely priceless. Like, it has so much information about leaks. Like, you could find just by that, their bank, their social media accounts, their email providers, credit unions, like you name it, like it's probably something on there. So I think the fewest I've seen someone have is like 4 or 5 things on there. So it's definitely one of those websites. And thankfully, it's not very technical. Like I said, even if you have a friend that's not a techie like you are, just give them the website. They type their email address in there, and they know immediately where they stand, which is not going to be a good stance at all, because that's just the way it is. Like you said, that's life online. It's the way it goes.
And if you want to be surprised every now and then, just set up a reminder. The website lets you do that. You add your email there, and whenever you're part of a leak, you'll receive a message saying that, yeah, you're part of this leak that affects this service, and you should change your credentials.
Yep.
It's a rude awakening every now and then, but it's useful to know that, and it's very quick. So
Yeah.
useful service there.
It's better to know than not to know.
Moving on. AI attack vectors, that's a trend that's not going away anytime soon. As this thing gets more and more money pumped into it, more and more people are using it. And one issue with people using more and more AI tools is that they are starting to use it for things better addressed by other tools. Meaning that people are starting to use AI tools and chatbots as if they were search agents. They're making queries there as if they were Google, for example. Or
Yep.
even worse, the search engine is giving you results as if it was a chatbot. Google gives you AI results at the top right now, which is silly.
Yeah, and it's very unreliable. It's very useful at the same time. I've been using AI a lot lately. I find that it's a lot easier sometimes to look up a command string or an option for a command. It's quicker to do that in AI than it is for me to go to my books, find the chapter, check the index, and find out what page it's covered on, or even quicker than a Google search. So I've been using it a lot, and I've been finding it very inaccurate probably 2 out of 5 times. I use both Claude and ChatGPT. And what I'll find, for example, is might forget a DNF command option that I don't use all that often. So I'll just type it in AI and then, oh yeah, that makes sense. So I type it into my terminal and it doesn't work. And then I go back to ChatGPT or Claude. I'm like, well, that didn't work. And it's like, oh, in DNF5, that's different. Try this. And it'll give you something else to try. It's like this conversation, it tells you try this, you try it, you report back whether or not it worked, and you try until you get to the right answer. At least 2 out of 5 times I have to go back in and fix it. And even though AI is useful, I still kind of feel like it's just a little too soon to implement it at the scale that we are, because in the enterprise, something could take 10 years before we trust it, but AI hasn't been around nearly as long in its current context. And then worse, you have, a story, I believe, where someone was looking up what a cure was for a disease, and AI told them to drink cyanide because it's not wrong. You won't have the disease anymore, but you also won't be alive. We get these weird responses. And now with this story that we're talking about right now, imagine you want to log into your online banking and you just lost your bookmarks, or you're trying a new browser. What's the login to Wells Fargo, Bank of America, or whatever you're associated with? And it gives you the link, the URL, and you go to a website and it looks like Wells Fargo or Bank of America, but something's a little off in the URL, or something doesn't quite add up. And then you realize that it's a phony website. So what we're finding, or what's being reported, is that there's an increasing number of errors when it comes to URLs that direct you to logging into a service. That instead of taking you to that service, they're taking you to a fake page not owned by that particular company, a page that's trying to steal your credentials.
So the issue here is that if you look at SEO optimization, Google has been gamed for many years now. Companies know how Google ranks pages, and they will create content that ranks better in order to be better placed at the search results. And people know this, and people have been gaming the system, and you can even pay for more clicks or for more hits on a given keyword and all of that. That has been known and possible for many years now. What Netcraft is a company that came out with the report that we were talking about how it's possible for LLMs to fall for phishing scams. Essentially, the problem is that it's possible to game LLMs and have them report URLs for things that they should not be reporting. So the thing here is that when you're trying to do SEO optimization for a malicious website, for example, as you were saying in your example, you want to create a malicious website that gets users that are trying to reach Wells Fargo. You want to get your website to rank higher than the official Wells Fargo website on Google search. That is very expensive. That takes a lot of time. That's very costly, and that usually is very difficult to do. Getting LLMs to give you a malicious URL when somebody asks them, oh, I deleted the bookmark for my Wells and Fargo login page. What's the login page for that? And having the LLM return you something that's fake, that's a malicious website, apparently it's possible to do. And the way that it's possible to do this is that you game the system and you create the website and you create the links to that website in a way that's friendly to the LLMs. Meaning that LLMs are training on all the data on the internet. Everybody knows this. They are constantly scanning the entire internet. That's why these models are so large. And it's possible to create content that's easier for LLMs to parse than other types of content. This is especially true if you're very concerned about your content and you don't want the LLMs to scan your website. You can set up your robots.txt and explicitly disallow the LLMs from actually scanning your content. But the threat actors, they actually want to be scanned by the LLMs. They want to be part of the training data, so that when people ask questions about that particular service, their website is going to get ranked and their website is going to be part of the response. Since people are starting to use chatbots essentially as search engines, this is how you game the system. This is a new threat avenue for malicious actors to go through. And apparently this has been working. According to Netcraft, they ran a small test on this. They queried for 50 brands, and they got back 113 supposed login pages for this. 2/3 of it were correct. The remainder, 5%, were from websites that had no relation at all with the actual companies that were being searched for. And the other 30% were everything from URL from websites that were not registered, from DNS names that did not exist, stuff that was just parked. Essentially, results that could essentially be bought by anybody and be used as a front for a malicious service. The one for Wells Fargo, that's particularly egregious because when you ask Perplexity AI for the Wells Fargo login page, it wouldn't return you the actual Wells Fargo login. It would give you a site that's hosted on Google Pages, essentially a malicious website made to look like the Wells Fargo website, and you would insert your credentials there and you would get your data stolen. The thing is, when you're searching for a login page and when you're querying for that, you don't know the address yourself. So it's not that easy to look at what the LLM returns you and essentially say, okay, this is fake, this is not the one that I want. Because URLs can have infinite variations. It's very possible that you got a .org result instead of a .com and the rest looks essentially the same. So you would be easily fooled by this. And again, for all of those listening that say, oh, that would never fool me, yeah, it would. It happens all the time, and most of the time you don't even notice it. And when you're searching for this, you essentially don't know the true result. So there's no way for you to gauge the result and ascertain if the result is actually correct or not. So that's an actual problem.
It's essentially poisoning the well, the AI version of that. It's manipulating the data, creating a false ecosystem around, a hack. It's like, oh, I'll create a GitHub page for this. I'll create this, I'll create that, and create some things online so where, the LLM is going to go to scan, it's going to find it. Oh, that looks right. Oh, that looks right. It's got the Wells Fargo logo. It must be right. And I think this just goes back to my opinion that implementing AI on all the things is premature. And the reason why this happens is because all it takes is one company to come out with a technology. I don't care what it is. If Google comes out with something, Microsoft comes out with something, doesn't matter. Once a company comes out with something, then all the other companies have to answer that. Okay, the shareholders are interested in the company that they're investing in, keeping up with their competitors. So they really don't have a choice. Google's doing it, we have to do it. And then you find it in browsers. And, there's even been talk about Linux distributions having it right in the command line. We're putting AI everywhere. But the problem is we really can't trust it fully yet. And the information that we get back, we have to vet that. I mean, when it comes to my earlier example of trying to find a command variation, like maybe I forgot a flag in the find command or rsync or something like that, and I looked that up. If I was to paste that into a terminal without looking at it and knowing exactly what it's doing, I could wipe my whole file system for all I know. I mean, these things can happen. And when you're logging into a service, when it comes to credentials, that's especially nefarious because, like we were talking about, it's poisoning the well. AI thinks it's providing you information that's valuable and correct. And the worst part about it is they usually, AI agents, and I'm sure people have noticed this, they pep themselves up. Like you say, give me the name of this movie starring Kevin Costner. And then instead of saying the movie is, they'll say, oh, movies are great. I'm glad you like movies. I'll help you find this. I'm going to find this information for you. Here's the information about this movie. And it's like they pep themselves up when they talk and, in the chat agents. And it just makes it seem like, oh, wow, that's a confident chat agent. It could be that the title for the movie you were given was completely wrong, but it's going to, it's going to kind of put some decoration around it, some, good grammar and things just to make it sound that much better, more human. But more human makes us trust it more, and we're more likely to click on a link. And the same could be true of any link. Just like you were saying, a lot of people might think, well, I would never fall for that. And just like you said, yeah, you will. I mean, all it takes, even if you're like the most, you have the critical thinking skills that are super sharp, all it takes is one day without as much coffee or one night without as much sleep. You're not thinking clearly, or deadlines are making you anxious. I mean, we're all human. And sometimes, depending on our situation that current day, we might be more prone to something than we normally would be. And I think this just underscores the fact that when we get something back from AI, it's useful, but we have to make sure that it's correct.
And even though this type of attack is essentially just starting up, there's already iterations and there's already developments on how this is approached. Another campaign that was identified was for an attack on the Solana blockchain. So the threat actor created a fake API. The URLs looked perfectly reasonable. api.solanaapis.com was one, and it wasn't just about creating the API. The attacker published code on GitHub, created blog tutorials, forum Q&A, dozens of GitHub repos to promote it, multiple fake GitHub accounts to share the project that used the API, and created accounts with bios, profiles, social media accounts, coding activity. And the goal was that whenever somebody wrote code that used this API to communicate with the Solana blockchain, the transactions would be rerouted to the attacker's wallet instead. So all of this work, all of this effort went just to divert the transactions. So the AI used this data as training material. It saw that it had lots of connections, it was very valuable, it had lots of information attached. So when you ask your Visual Studio Code or when you ask Cursor to help you write an application that communicates with Solana, it's very likely that the code that you're going to get back includes a link to this type of API. And you're going to get that suggestion. And you will know absolutely no better, and you will use what it's giving you because it works. And you've essentially fallen victim to the scam. And it's really tricky to detect this when you don't have the ability to vet the data. In your case, you're pretty familiar with DNF, but there's these obscure commands and these obscure command line options that DNF has that nobody uses more than once in their lifetime, that you're not sure about it. And when you ask for some way to use that and the AI agent gives you an answer to that, you will probably fall for it because you know no better. You have no way of knowing if it's actually correct or not. It's telling you to do that, so you do that. Yep. That's why you're looking up the information. If you already knew how it was done, you wouldn't be asking it. So yeah, there's that.
There's absolutely that. So I think that pretty much summarizes it. Just make sure you check, the types of things you're getting back. And this is absolutely not the last story that we're going to cover where something being returned from AI is having negative impacts. It's just the way it is. I'm sure over time, AI is going to be more accurate. It'll never be 100% accurate, ever. But I do feel at some point it'll be a lot more accurate than it is today. But it really is early days with AI. I mean, this is just the very beginning of whatever this is going to end up being. So we have to kind of just treat this as we would treat a file system on our Linux server that only had a few years of development, right? I mean, most people, seasoned sysadmins, won't even use a file system that hasn't been around for at least 10 years. And I think we really need to kind of keep that, right? We do kind of need to keep that mentality because especially in the enterprise, we really should be relying only on the things that are proven. And right now is just not that time for AI yet.
Yeah, I guess we can cover the Ubuntu story right now because it's going to touch on Linux as well. So yeah, a few years ago, you might remember these names made the news rounds: Spectre, Meltdown. These were CVEs. They relied on exploiting hardware flaws, in this case being the CPU. There was some speculative execution pass in the CPU, meaning that when it was running a specific instruction, it would try to guess the instructions that would follow and it would start executing those, and then it would kill off the branch that it wasn't actually the correct one. This would speed up computation, you would get a speed bump from it, and at the time when Moore's law was falling off and you wouldn't be having the performance benefits that you were having 10 years ago, where each generation would give you a very nice boost in performance. You were just getting more cores or new instructions and all of that. Any way that the chip makers could use to get more performance, they would take it. So speculative execution was and still is a thing. And at the time, Spectre and Meltdown, those were vulnerabilities that targeted that specifically. To get around those, there were some mitigations that were created. These were mitigations for the microcode for the CPU. These were mitigations for the operating systems, and all of those had to be applied. The downside to this was that those mitigations would essentially either completely disable the speculative execution pass, meaning that you would lose performance, and the performance loss here was pretty noticeable. We're talking about 20%, 30% under some workloads. And people applied them because, yeah, it's a vulnerability. I'm not going to get my system hacked just because of this. But the performance price that was paid for this, boy, was this expensive.
Yeah, it really was. And yeah, I remember when this came out, I had a new computer at the time, and this is back in 2018, if memory serves me right. And it's like, oh, I just bought a new computer, and now I'm talking about a potential 20% speed decrease. Now, the fact of the matter is, when you're dealing with the CPU, okay, it's one thing to have an operating system. You could patch an operating system. You can just do apt update, apt dist upgrade done, or Fedora sudo DNF update. You download your patches, you mitigate any vulnerabilities, restart if you have to, but the CPU cannot be patched, at least not in the same way that an operating system can or a piece of software. So instead, you have microcode and RAM that will offer some mitigations. So of course, there's going to be a time period when your computer is starting before the microcode is loaded that you might still be vulnerable, but like Joao said, it gave you up to like a 20% or some number of a speed decrease, and that's pretty bad. It's actually really bad with different workloads, because database firms that need to process data for their clients in a fast amount of time, it made them scramble to try to see what they could do to get around this, or just not lose as much speed. It was just a big hit for some people more than others. Obviously, if you just use a Linux computer to check your email, you're not going to notice a difference. But depending on the workloads, you will. And what I thought about back then is, this is not an easy attack vector for threat actors. Yes, they can do it in theory, but if you have somebody that really wants to break into a system, are they going to use Spectre and spend a very long time going through information stolen from a CPU to try to get into the system? Or are they going to go to the CVE list, find out what software is being run, and try to find a vulnerability that way? Usually they're going to go with the latter. But the problem is, even if an attack vector isn't extremely popular, that does not mean that you're protected from it. That does not mean that there's nobody out there that's going to go through all those hoops to break into your system. But when you're dealing with a big performance drop, as we talked about in the industry back then, it's like, okay, we're mitigating something with a big performance penalty that may or may not be actively exploited in the wild as much as other things. So there's that argument. But then with security researchers like you and I were talking about before, you mentioned that just they could, and if you don't mitigate it, then they definitely might. But it's still a big performance drop. Now, when the news recently is that Ubuntu is going to reportedly roll back some of those mitigations. Now, you got to be careful when you read articles. I noticed this lately, especially the way things are reported can paint a different picture. Some people might think, oh, the CPU is going to be faster. No. If you read the article, it's GPU workloads, and specific GPU workloads, that are going to see a performance boost, because an argument is made that maybe the mitigations are just too hard on the system, and maybe in some cases they could be relaxed a bit because the attack vector isn't really as popular. Is it worth the speed decrease? So certain workloads that are GPU related, and the article that we linked to is mentioning specifically Intel with OpenCL is going to see some performance improvements. So I thought it was worth mentioning just on account of that, but also this is the kind of trade-off when it comes to security. It's like you mitigate something or work around something, there's often a trade-off, there's often a downside, or there's something that might not run as well. That's usually the way it goes. But with Ubuntu eliminating at least some of these protections that they don't feel are as relevant, I think that kind of does open the door for other distributions to kind of look at this too, and just find out how much of this performance drop is really necessary. Is it worth it? And I think that's kind of where their headspace is at when they came out with this.
So The logic here being that Ubuntu by default used to have these mitigations enabled for everything, for the CPU, for the GPU, the compute runtime, and apparently they decided against that. They decided that they no longer want this to be enabled by default. Like you just said, it's tricky to exploit, and the reasoning being that everybody's paying a very high price for something that might never be actually exploited. On the other hand, that's exactly the type of vulnerability that gets breached, especially now that people know that it's no longer going to be protected by default. So yeah, I'm going
Right.
to use
That
this vulnerability to attack an Ubuntu
oh,
system.
they're relaxing protections. That's putting a target on the backs of some of these things.
Now, this specific one on the GPU side of things, this is especially relevant for high performance computing. This is especially relevant for two particular use cases. The first one being AI. If you're running local models or you're running inference or training and you have these big systems running Ubuntu, which many people do, essentially disabling this gives you performance for free. You already paid for the hardware, it was being hampered by the mitigations. If you disable them, you were able to train faster. The other use case is for cryptocurrency mining. That also gets affected when you turn on these mitigations, so disabling them will give you more cryptocurrency for the same equipment. Yeah, you won't notice it if you're using this at home to play games. It's not going to impact that, but it's going to impact very intensive calculations that you're running at the GPU level. And the change here is just the default stance. The big Ubuntu distribution names out there, the Red Hats, the Canonicals, as soon as the mitigations were available, they started enabling them because, yeah, they want their systems to be secure, and you're not going to be putting out an operating system without the guardrails in place.
In one of the comments I read online, I wish I could remember where exactly this was so I could give credit to the person and also offer a direct quote, but I'll summarize it that when it comes to multi-tenant situations, and when I say multi-tenant, that usually means private cloud or something of the like, where you have, you know, a virtual machine server, especially in cloud environments where, obviously a cloud provider is not going to go to Dell and buy a brand new server every single time you want to spin up a VM just for you. Obviously, they do offer dedicated machines, but more often, you could have some number of different, completely unrelated accounts on one server. And the person basically brought up the point that, yeah, it might be fine to roll back some of these protections. However, when you have a multi-tenant situation, this kind of attack is a lot more valuable because it's one thing to break into Acme's Linux server, but imagine a cloud provider. They're a bigger target for this kind of thing because the whole point of a cloud provider is to make sure that company A can't access company B's servers. Like they're completely, separated from one another. But threat actors are always looking for a way to jump from one account to another, or break into the greater system. Imagine if a cloud provider got hacked and then all of the tenants were, hacked. Um, that's why I think the person basically saying that this kind of thing's a bad idea to roll back protections in multi-tenant situations. I agree with that because while it might not be a popular attack vector when it comes to, a random company server, there's probably easier ways to break in. But when you have a cloud provider, that's a gold mine. I mean, you could have, depending on the size of the cloud provider, hundreds, tens of thousands, hundreds of thousands, millions or more different clients that are using the hardware, and being able to break out of the sandbox, so to speak, and get into another company's servers. That's what threat actors would love to be able to do. And yeah, they would absolutely utilize something like this. So I think as long as we're careful about what protections we remove and in which environments we remove them from, I think that's a really important thing for the industry to keep in mind.
Interesting that you mentioned that. One of the workloads is running virtual machines on the cloud at the hyperscaler level, where you have lots and lots of tenants on the same hardware. On the other hand, stuff like running serverless and running functions and running containers is also a potential target for this, because your workload is running on the same systems and many other workloads are running. So one of them that's malicious might impact the others.
Right.
Yeah, The hyperscalers for sure are not going to be disabling this. On the other hand, the actual cost of these mitigations is not just the performance one. This particular performance degradation has an actual monetary value. When you purchase equipment, when you purchase latest generation CPUs, right now the speed bump that you get from one generation to the next one is probably less than the hit that you're going to get when you enable these mitigations. Meaning that you're buying the latest CPU, but when this is enabled, you're essentially running at the level of the last generation or even previous that. And you're still paying the premium for having the latest CPU. So
Right.
there's an actual monetary value to having this enabled or disabled.
Yeah, and obviously when you invest in hardware, you look at the features, you look at the clock speed and all these different things, and you make a decision on what hardware is right for you in particular. You make that decision and then find out you're going to have less performance just because of a mitigation. And that is absolutely true. So it is like it's almost like stepping a generation and a half back, not just one, because that's a pretty sizable. I mean, sometimes big chip makers might just say, "Oh, there's a 10% increase," or it might not even be a major CPU refresh, but it's almost like they do a minor update and a major update. If it's a minor update, that's going to be even worse.
Back in the day, I still remember the Pentium 4s and the AMD Athlons when year over year, you'd get almost a 50% or a doubling of CPU performance. You're
Yep.
not getting that anymore.
Nope.
And just touching on the last story that we have today, and we're already running long. If you want to cover this one.
Yeah, I'll cover this one real quick because I think of the stories that of all the stories we brought up today, this one is the least impactful to enterprise because I'm just going to talk real quick about a situation with evil Minecraft mods where basically a group called the Stargazers Ghost Network has been essentially releasing infected jar files. Those are Java files, and people that play Minecraft know about Java. They're probably one of the few that know about Java nowadays. Of course, I'm kidding. Enterprise uses Java a lot, but just imagine if someone's playing a game, this mod is really great. It could maybe change the UI or maybe change the game. They download it, and then what ends up happening is that it starts stealing information. Now, um, obviously, when it comes to enterprise IT, I don't really think anyone should be playing Minecraft at work. It's most likely against the policy at your company to use your work computer for playing games. But increasingly, what I find is the bring your own device situation where an organization might save money by not buying computers for all of their employees. They have something to depreciate. They have inventory to keep track of. They might create a bring your own device policy where you could use whatever computer you have if you work from home. Now, I'm actually for the bring your own device movement, but with an asterisk only if proper protections are in place. We could probably talk about this in another episode. Obviously, if you allow employees to use their home computer for work, you're opening the floodgates for potential situations, assuming that you're doing everything right and you're keeping an eye on things. That's fine, but the situation is, obviously we would never do this because we're tech people, but imagine someone whose job role is not IT. It's just something non-technical, so they're using their computer at home to do their job, and they let their kids play Minecraft on the computer because, well, it's Minecraft. What's wrong with that? And then all of a sudden they connect to the work network and then things start to get stolen. That's just something that can happen. And I bring this up that there's some of these Minecraft mods, and it's the Stargazers Ghost Network that are reportedly creating these. It's something for people to be aware of that happens. It's something to check for. In Java is something you've got to kind of keep an eye on anyway. I mean, the tagline, and I made this joke constantly: write once, exploit everywhere. It's actually write once, run everywhere. But that joke was coined by the Security Now podcast, and I just love it because it's the case. We've had a period of somewhere between 8 to 10 years where infected Java sites and jar files were just a normal thing on the news constantly, that it was something that people should check for. Just bringing it up because this is something that people are doing. It's something to be aware of. Obviously, I'm not sure we have a lot of Minecraft people in our audience, so I won't spend too much time on this. But I just wanted to bring it up to be aware of it, that there's these infected mods and cheat utilities and things. And what they do is they bypass protections by looking for certain things that are running on your system, like Wireshark or something that could be used to detect it. They shut themselves down, and then they bring in another service that starts to steal information and then uses HTTP post to send information to a command and control server. So these are created for the purposes of stealing information. And it's one thing if it's a residential computer that has this, but if a work computer gets something like this on there, then that's even worse.
It's interesting that even for attacking something as low-hanging as a Minecraft server, trying to attack specific Minecraft users, and creating and going to the length of creating malicious jar files and adding all of these features to that, that's something that's easily done at this point. Creating malware that includes evasion techniques that detect if it's being analyzed, if it's running alongside any detection tools like Wireshark, or if it's running inside a virtual machine. That's just the basic line, the baseline ransomware at this time, the basic threat software that you need to handle. And even something that's as simple as this already includes that type of functionality. It should give pause, and you should consider that, yeah, the stuff that's trying to target specific enterprise components, it's going to be much more evolved than this. It's going to include much more functionality than this. It's going to be much more advanced, and it's going to do and hide much better.
Right.
And this is just an indicator of the current state of the industry. It's always interesting to see the evolution of this type of attacks and this type of tools. And yeah, again, I keep repeating this, but this continues to be true. The bad guys have a lot of resources. They have financial motivations most of the time. They have the resources to do this properly. They have the know-how on how to do this type of things and create this type of software and make it really tricky to detect. You're never going to be 100% sure if something like this isn't running on your systems. But you need to keep an eye on for as much strange behavior as you can and try to detect these things as soon as they pop up, because otherwise you're going to get hacked.
Yeah. So if you have any scanning software installed on endpoint computers, that maybe just add jar files to the list, not just because of this. You should be checking for that anyway. As I haven't looked at any Java usage statistics lately. I know Enterprise usually holds on to things far longer than anyone else does, so I'm sure it still has a presence there. But Minecraft is definitely one of those things that keep it alive. That's definitely the case. So
the Enterprise has it. There's lots of stuff running on Spring Framework, for example. That's Java.
Right.
There's lots and lots of stuff running on Java.
Yep, and this could be used as a stepping stone to get to something more interesting if someone's trying to poke through a network. So just stay vigilant. I think that's the moral of this story. Actually, probably every story we bring up is just educating everyone on the things they're happening. The stories we bring up might pertain to you. Some of them may not, depending on your individual situation and your organization situation. But having a general knowledge about what's being tried and what's going on out there can help you make better decisions as a sysadmin, and educating everyone about those kinds of things, well, that's what we do.
And that's our show for today. Thank you everybody who joined. As always, it's a pleasure, and until the next one. Bye.
Thanks. Bye.